Let's take a look at how we solved the problems on our most recent test. We are going to have a test retake. And so you can turn this in for a grade, and you should turn it in for a grade. All you got to do is kind of follow along, take notes, write down work, and solutions. So let's get started with the first problem, which is find the f of -2 and show your work. There's a couple of ways to do this. Way one, which I think many of you probably like, is to just go, okay, f of -2. So where there's an x, we replace it with -2 in our notation. And then on the right-hand side, we substitute in -2 every time. Let me highlight those substitutions so you can keep track of them. So there was an x. I replaced it with a -2, this blue -2 right here. Then it goes plus, and I'm just following along, 9, and then it's x squared, so that x is now a -2. Minus 2, there's another x, so that becomes a -2. And then minus 1. And again, we just work on the right-hand side here, so we just have to simplify this. So it's -2. -2 cubed is -8. Plus 9, -2 squared is 4. -2 times -2. 16, 36. I think this comes out to 56 minus 1, so you get a 55 for a solution. So you certainly can use that method right there. It is not the method, however, that I would use, and I would say that's relatively inefficient. A much quicker way to solve this problem, I'm going to leave the answer down there at the bottom so you can see how much quicker it is to solve it using synthetic division. So this is the f of -2. This is what we should get for an answer if we use this other method, so we can verify, and you'll actually see that it is much quicker. All you have to do for solving this, really the fastest way, is put the -2 in your synthetic division box. Write down your coefficients, -2, 9, -2, -2 and -1, and we just carry out synthetic. Bring down the -2, we multiply here, we add, we multiply here, and we add, we multiply, and we add, and see we get the 55 there. So f of -2 is our remainder, 55. So this is the remainder theorem in action. What we did is we took f of x, divided it by x plus 2, and that means put the -2 when you do synthetic division inside that little box. And the remainder will be what the f of -2 is, much quicker than doing the substitution method. The next problem, there we go. We have to choose the graph below here. It's hard for you to see them all, but there they are. Choose the graph below there that has a couple of characteristics. It has to be an even function. And so you just have to memorize this. Even functions, their ends always behave like each other. So if one goes up, they both go up. And conversely, if they both go down, or if one goes down, they both go down. So since we're looking for an even function, we want one with the end behavior doing exactly the same thing. So if you look at this first graph here, the left end goes down, but the right end is going up, so that can't be even. The second one here, B, they both go up. Okay, in C, one goes up, one goes down. And in D, they do both go down. So one of those is our even function. It's either B or D at this point. And the negative lead coefficient tells us which one it is, because negative lead coefficients always go down on the right-hand side first. And so this one right here goes down on the right-hand side. The other side has to follow along because it is an even function. And so clearly at this point we know it is D. B up here would be a positive lead coefficient. It'd still be even. It'd be a positive lead coefficient because the right-hand side goes up first. Describe the end behavior of this function. So this is very similar to the previous problem, but this time we have to pick out the lead coefficient and the degree. So our degree is 5. And we don't really care that it's 5. What we care about in this problem is that it is odd. Okay? And odd functions either do this, one goes up and the other side goes down, or vice versa. Left side goes up, right side goes down. So we know it's doing one of those things. Then we look at our lead coefficient here. And the lead coefficient is -4. But that, more importantly, is negative. And so that tells us what the right-hand side does, which is go down. So we know it's going to look like that pink function I drew. Let me redraw them right here. Odd says they go in opposite directions. The negative says the right-hand side goes down first, like so. Then the graph will do something, but then the left-hand side will go up in the opposite direction. To describe this end behavior, we write two statements. We say what happens when x goes to the right and what happens when x goes to the left. That's positive infinity to the right, positive x's, and it's negative infinity to the left, negative x values. So what does the function do? So you just kind of trace the function to answer this. You say, okay, as I go to the left, where does the function go? It goes down, down, down. It goes to negative infinity. So we write the function goes down to negative infinity. On the left-hand side, we just kind of trace to the left, and we say, where does it go? It goes up, up, up to positive. That's positive y values. So on the left-hand side, it goes to positive infinity. And that's it for that problem. Next one, which graph is for this polynomial that they've given us here? And so I've got Desmos pulled up here, and that's all you want to do. Use your technology when it's available to you. So let's go ahead and put that in here. There we go. You can put f of x or you can put y. I'm going to use y equals negative x cubed plus 7x and plus 6. So there's our graph. And so if we're trying to compare and look at the graphs that we have, you can see in the graph that our Desmos gave us, right-hand side's going down, left-hand side's going up, and it's got this nice little reflection in the middle. So right away you can tell it's not A here, you can tell it's not B. It looks very much kind of like B here, but the right-hand side goes up. Here the right-hand side goes down, so there's that curve. Now you can check particular points. So in your graph, find some key points, like hopefully this will press for me. There we go. You can kind of see it there. Erase that. But you can see that point 0, 6 right there. So let's just check to make sure. This thing is going, it looks like by 4s. You can see how it's an 8 right there. Let me zoom in on that for you. But this is 4, and this is 8, and so halfway would be 6 right there, and that coincides with this. Looks like it crosses right here at x is -1, and it does there, and x is -2. You can actually get Desmos to show those for you. And so we can clearly see that the answer is D for this problem, just by comparing it to a Desmos graph. Next problem, we got to do just a little addition here. Okay. I'm going to do a variation on this problem. You guys all did very well on it. So instead of doing the addition problem, I'm going to do a subtraction problem, just to make sure we're good with that when we take the retake of this. So let's change this to a subtraction. Let's work that problem instead. Okay. If it is a subtraction problem like that, what you need to do is you got to make sure you distribute that -1. And all it does is flip everybody's sign, so it becomes a positive x cubed and a negative 5x squared. I'm just changing everybody's sign. And then we just start looking for any like terms. So like this is an x cubed and that's an x cubed, giving us a total of 2x cubes. 1 plus 1. Let's see here. Next would come x squareds. I lost 3 and then I lost 5. Lost 3 minus 5. That's -8 x squareds. Then let's see, here comes x's next. Let's pick a darker color for that. There we go. X is next. It's +4 take away 2. +4 take away 2, so that's 2 x's. And then lastly, we got this -16. And we'd be done. 10, a big multiplication problem. So let's take a look at this guy. Let's distribute the 5x. 5x to the 4th minus 25x squared plus 10x. Distribute the -3. That's -3x cubes plus 15x minus 6. It's 5x to the 4th. It's this one. Let's look for any x cubes. -3x cubes. There's an x squared, 25 of them. 10x plus 15x, 25x. And lastly, -6. And there it is, simplified. Pascal's triangle problem. All right, now you could work this out by cranking through it by hand. A couple of things we want to note, though. As soon as this gets like to the 4th power, it's quicker with Pascal's triangle. Second thing we want to notice, we only need to find the second term because that's all they asked for. We'll find more than that when we do this problem, just so you're prepared for whatever we asked or you are asked for. But the process is the same whether you're finding the second, third, fourth, or all of the terms. This is called a binomial expansion because this is a binomial, 2 terms, 2x minus 3, it could be 2x plus 3, it could be x plus y, just 2 terms added or subtracted together. And it's called an expansion because you're going to multiply it all out, a binomial expansion. And to do it quickly, we'd write down Pascal's triangle. We have lots of videos on this, and you can find it readily on the internet, how you generate that, but you can see you can write it pretty quickly. Now this is a 4th degree polynomial, or a 4th degree expansion, so you want to go to the line with this 4 in it right there. And you write down those coefficients, 1, 4, 6, 4, 1. Next, identify what a and b are. A is just the first term in the binomial, 2x. And b is, you got to take the sign with it. B is -3. All of this is based off of a binomial written as a plus b. So in this case, a is our 2x, b would have to be a -3. Again, focus on this 4th degree. So here we go. All we have to do now is take the a value, which is 2x, and write it to the 4th power. And the 3rd power, I'm using 4th power at the beginning because it's to the 4th. And you just keep going down by 1 degree. So I went 4, 3, 2, and 2x to the 1st. We don't usually write the 1 for 2x to the 1st. And then we do 2x to the 0. So it was 4, 3, 2, 1, 0, but 2x to the 0 is just 1 again, so it'd be 1 times 1, so we don't show it. Then we take the b term. The b is our -3, and our negative 3 does the opposite. And I usually start my b term down here, and I say, okay, well, he's to the fourth power, but then he goes in descending order to the left. There's negative 3 to the first power, and then finally negative 3 to the 0 power. So the negative 3 goes 4, 3, 2, 1, none. Now, the way this is generally described, though, is our a term has gone descending order, 4, 3, 2, 1, none. And our b term has gone ascending order, no b terms, b to the 0, to the first, to the second, to the third, to the fourth, so it ascended. Now to figure out these terms, all we have to do is simplify each one. So we take 2 to the fourth power, that's 16, and then our x to the fourth, and then times this blue 1, but it's just 16 still again. The next one, we've got a 4. We got to cube that 2. So that's 8x cubed times that negative 3. So we have to do 4 times 8 times 3. That's 3296. It'll be a negative 96. Then we go to the next term. And hopefully you see the process at this point. Next term we got a 6. We square the 2, so that's a 4, and square the x. We have to square the negative 3, that's a 9. And now we got to multiply the 6 times 4 times 9. It's 24 times 9. 24 times 9. 36, carry a 3, 18. 216. X to the second power. And you just continue on with this process, simplifying. See, we've taken care of the first one. Here we go. Take care of the first one, the second one, the third one, and you just keep going. You've got those two left to do. The question was, what's our second term, though? And so it is the second term, negative 96x cubed. This would be our third term, 216x to the fourth, etc. Next problem, which of these down here is a factor of that polynomial? To figure out factors, they have to divide evenly into the function. So let's just see which one of these divides evenly. But I want to give you a quick side note on how you might be able to solve this much faster in some cases. Open up my browser and go to Desmos. And I'm just going to graph this function really quick. Because remember, if I graph it, I can find zeros. If I can find zeros, I can find factors. So y equals, and we'll go 3x cubed minus 11, I hope here. There we go, minus 11 x squared plus 12x, oops, and minus 4. And so now I've got the graph of it. Let's take a look at a few of these points here. Okay, so one of the solutions is 2. Let's see here. It looks like one of the solutions is 1, and another solution is 0.6, repeating, which is 2/3. So 1, 2/3, and 2. And now you'll notice there's two factors over here that have a 2 in them, or possible factors. Now remember, factors should give us solutions. So, for example, if x plus 2 was a factor, set it equal to 0, that tells us x is negative 2 as a solution. But we found over here in our graph that 2 is, and that's what x minus 2 gives us. You can see if I set it equal to 0 and solve it, x is 2 is the solution. So x minus 2 is a factor. Now, what we want to do is double check that, though, in case we goofed up our graph. So how do you find out? You just divide this function by x minus 2. How do we do division like that? We use synthetic. Put a 2 in the box. 3 3, negative 11. I'm just writing down the coefficients. You can see my remainder is 0, and therefore x minus 2 is a factor. We did a lot of factoring problems throughout this unit. This is a 4-term polynomial, so we group it. You should show this in your work. Just don't give me a factored solution, because we know that you can look these things up online, but the work you can't always find. So in this case, I grouped the first two, GCF out of x squared. The second pair, I'm going to take out a negative 16, leaving me with x plus 7 as well. We pull out the x plus 7, which is the common factor. When I take it out of here, I'm left with the x squared minus 16. And I can go one more step. This is a difference of 2 squares. This is an x squared minus a 4 squared. And difference of squares, x minus 4, x plus 4. And there is the complete factorization. Write a possible polynomial for the function that is graphed here. So what we want to do is find the zeros. We just kind of talked about this. Looks like it crosses at negative 4, so that's a solution. It crosses at 2, so that's a solution. And it comes up and touches right here at 0. And whenever it just touches it and turns away like that, that's 0, but it's 0 because this is the point, 0, 0. So the x value is 0 right there. But that indicates multiplicity. Just means 0 is an answer more than once. So when we write our polynomial here that gives us this function, it's always x minus solution or root. So it'd be x minus negative 4 then be x minus 0. But we got to do that twice. I'll write it down below. It's minus 0 for my second one. And then lastly, x minus, and then we have the solution of 2, so x minus 2. So those are all of our factors. Now these can be cleaned up as needed. Okay. In this case, f of x, double negative in that x minus negative 4, so x plus 4. X minus 0 is just x. X minus 0 is just x, and then x minus 2. So this x times x we'd write as an x squared, and then we've got our x plus 4 and our x minus 2. Now, once you get the hang of this, everybody, hopefully you realize anytime you get 0 for a solution, like we did in this problem, x is a factor. And then since it happened twice, x is a factor again. So right away we know x squared, that gives us that 0 with multiplicity, and then we just have to figure out the other factors, x plus 4 and x minus 2, just by looking at those solutions. 12, let's list all our possible factors. So if you remember, this is called the rational root theorem. P, factors of 6. These are all the numbers that divide evenly into 6. And then Q, factors of the lead coefficient, in this case negative 1. Well, the only thing that divides into negative 1 is 1, plus or minus. And so our possible solutions, each P over each Q, so it's 1 over 1. It's 2 over 1, 3 over 1, and 6 over 1. And that's our possible rational solutions. And that's it. Let's solve this polynomial. So it's equal to 0, which is fine. Let's list our p values and our q values. Let's find out what the possible solutions are. So p comes from the 3. It's just plus or minus 1 or plus or minus 3. Q, coefficients of the, or factors of the lead coefficient. And so if it has a rational solution, it's either 1 over 1, which is 1, or it's 3 over 1, which is 3. We could grab our graphing calculator at this point, and we could figure out which one it is. I'm just going to do them quickly with synthetic division to find it, though. I'm going to first test positive 1, so I put a 1 in the box. I write down the coefficients of my polynomial, and I just want to see if it gives me 0. And we can see it does not. It gives me a 4. Therefore, 1 is not a solution. So now I'm going to try negative 1, another possible solution. That's 1, negative 6, 6, 11. Nope, it does not work. Therefore, negative 1 is not a solution, and I move on. Next, we'll try the 3's. So I'll try positive 3. There we go. 3 is a solution, so I've got one value for x that I know works. And because I use synthetic division to test it, I have reduced or depressed my equation to 1x squared minus 2x minus 1. And I just have to solve this guy. X squared minus 2x minus 1 equals 0. We just have to solve him. I could try to factor him. He's not going to factor. And so I'm just going to use the quadratic formula on him. So let's list our A, B's, and C's. Quadratic formula, let's write it down up here so you can see it real quick. And all we're doing is substitution. So I just substituted in A, B, and C where they go. Some things you'll notice, like when it says up here the opposite of B, since my B was negative 2, it became positive 2. It says take the B and square it, so I took negative 2 times negative 2 in my head, and I got 4. And next you want to calculate what's called the discriminant, and that's what's underneath the radical here. So it's 4, and this would be negative 4 times 1, negative 4 times negative 1. So that's a positive 4. So this becomes 4 plus 4 under here, or 8. Eight factors a little bit. It is a 4 times 2, and we can square root of 4. So we square root the 4, which is 2, and this other 2 has to stay inside there. And we can see everybody's divisible by a 2, so we'll just simplify to 1 plus or minus root 2. So we got 2 answers here, 1 plus root 2, 1 minus root 2, and we also have this answer, x equals 3 at the top. I'm going to write the other answers up there with it. So there's our 3 answers. This is a cubic equation, so we should have gotten 3 answers. Last one. This is more of an ACT type or SAT type question. We want it to be divisible by y minus 2, so let's divide it by y minus 2. So we put a 2 inside our synthetic division box. We've got 1y to the 5th, negative 2y to the 4th, 0y cubes, 0y squareds, negative cy's plus 6. And we just carry out synthetic division. I know that c's in there, but that's all right. Note how I did that. When I add here, I just get negative c. 2 times negative c is negative 2c. And then I add those two together on the right, and they're giving me 6 minus 2c. Now, because I want y minus 2 to be a factor, divisible by y minus 2, this remainder should be 0, so I just write that little equation. 6 minus 2c, I want u to be 0, and we solve it. Subtract 6 from both sides and divide by negative 2. C has to be a 3 in order for the remainder to be 0, which would make y minus 2 a factor. And that is all of our problems.